Have you ever wished you had a personal book advisor? Someone who could magically understand your reading taste and suggest hidden gem you would absolutely love. Well, with the power of AI, you can build your own book recommendation system. In this tutorial, we'll dive into the world of text embeddings with OpenAI, calculate costs, get smart with SciPy, and bring our recommendations to life with stunning visualizations using Atlas. Are you ready to become a book recommendation wizard? Let's get started. Hello everyone and welcome back to my channel. In today's video, we are going to build together step-by-step an AI-based recommendation system. Recommendation systems provide us with personalized recommendation based on our behavior and interest. They can be found in a variety of applications, such as e-commerce, social media, or online content platform, to improve our engagement and satisfaction. A good recommendation system is a crucial aspect of building a successful online business. And to be as efficient as possible today, we are going to use OpenAI embedding. And I have already prepared a book dataset from Kaggle in a CSV format. Of course, instead of book, we can build our recommendation system for any other type of product, such as movies, music, TV series, or social media interaction. All right? Let us now start building our recommendation system. Now let's get familiar with our book dataset. It contains carefully selected book entries. Imagine it as a digital library. Let's break down the column which holds the key to our recommendation. Each row in the dataset contains information about a book, such as its ISBN number, the author, the category, description, publication year, and average rating. Let me show you where we should go. Each book description will be embedded into a vector using an AI embedding model and saved onto a pandas data frame, along with other available book information. When a user enters a book title, and if that title exists in the dataset, the system will take that book's description embedding and calculate the nearest embedding. Similar embedding implies similar text description. The application utilizes some utility function from the OpenAI library to compute the distance between the target embedding and all the other ones. The recommendation box with the closest description embedding will be printed out. For instance, if I enter Bill Gates, the application will suggest similar books. And it's important to note that the quality and richness of this dataset will significantly impact our recommendation system's performance. A well-rounded dataset is the foundation of a great recommendation engine. And again, this book dataset is from Kaggle in a CSV format, which contains information about almost 2,000 books. And as you already know, Kaggle is an online platform for data science and machine learning where users can collaborate, share resources, and compete to build the best AI model. Now that we understand our data, let's turn to Jupyter. I will show you how to generate text embedding from these book descriptions, which is the first step to finding those amazing recommendations. Alright, let's start by getting our code environment ready. We will install the following required libraries. Have pip install pandas and pip install numpy. Alright, let's run the code. OpenAI is the key library for interacting with OpenAI powerful AI model. And Pandas is our data wrangling superhero. It will allow us to organize and work with the book data easily. NumPy is the master of number. It provides lightning fast calculation, essential for handling our embedding. And I'm using the -q flag just to keep the installation output nice and tidy. Now that we have our libraries installed, let's import them. So we'll say import OpenAI, import pandas as PD, and import NumPy as NP. Let's run the code. And it's done. We installed the library and import them. In the next step, we are going to load the environment variable and then create our OpenAI client. Now in this part, we are going to load our environment variable and create our OpenAI client. Your OpenAI API key is like a secret password for accessing their service. We don't want to put that directly in our code for the world to see. Instead, we use a technique called environment variable. Think of them as secret nodes tucked away in your computer. So we'll say here import OS to access the file directory, and then from .env import load underscore .env and find underscore .env, and then we'll say here load underscore .env find env and override is equal to true. After that we'll say is os.environ.get OpenAI underscore API underscore key. Now for testing that the OpenAI API key loads successfully, we are going to print a message to say API key loaded. Say os.environ.get OpenAI underscore API underscore key. And the condition is not none. Let's run the code to make sure that the OpenAI API key loaded successfully. And we get the message API key loaded equal to. Now we are going to create our OpenAI client. So we'll say here from OpenAI import OpenAI and then client equal OpenAI. Let's run the code. Yes, and it worked. In the next part, we are going to load the dataset into Pandas data frame. Now it's the time to bring our book data into the action. Remember, Pandas is our data manipulation superstar. What we want to do here is to load our dataset into a data frame, and then we are going to do some cleaning by dropping rows with missing values. And after that, we are going to sort the rows by the average rating in descending order, and then we are going to choose only the top 1000 record. So we'll say here data frame is equal to pd panda.read underscore csv dot slash data set, which is our data set, and it is in the same directory. After that we'll say data frame dot drop an a in place is equal to true. And now let us have a look at our data frame. And before that, I would just want to mention real world data can be messy. So we use here drop an A because we want to handle missing entries. Think like a blank cell in our table. Drop an A finds any rows with missing values and removes them. The in place equal true means we are directly cleaning our original data frame. So let's run the code cell. And this is our data frame. We have the ISBN, the title, subtitle, author, categories, and description, which is the most important column we have here, because we are going to do text embedding for the description. And then we are going to compare text embedding to the nearest other text embedding to recommend box. And here we have average rating. We want now to sort the data frame based on the average rating in descending orders and select the top 1000. Let me comment this line, and then here we'll say df is equal to df.sort underscore values average underscore rating, which is this column, and we'll say here ascending is equal to false, and we want the top 1000 record. All right, and then we'll say df. Let's run the code cell again and check. Yeah, and we get here now the top 1000 record, and it's sorted in descending order of the average rating. So what we did here is grab the top 1000 entries from our sorted data frame. We want to work with high quality, well-rated books. The data frame contains nearly 2000 rows, but for initial task we will use only small portion of the data. We will embed the description of each book and pay for the 1000 tokens. Working with large dataset can be time consuming as well. Once the application is tested and functioning well, we can use the entire data frame. For now, we will work with the top 1000 books sorted by average rating. In the next part, we are going to calculate the embedding cost. Before we can calculate the cost, we need to understand how OpenAI measures the size of the text in processes. It uses something called token. It is not just about word. Think of tokens as puzzle pieces representing part of sentence. So first we have to import tick token library. This library is our handy token count assistant. Then we'll say encoding is equal to tick token dot encoding for model, and then we are going to use here text dash embedding dash 3 dash small. Here we specify the particular OpenAI embedding model we will be using. Different models might have a slightly different tokenization method. Now what we want to do is to grab all the book description from our data frame and put them in a list. So we'll say descriptions is equal to list of data frame, and we'll say here description. Okay, so we are getting now all these description and we are putting it all of it in a list. Okay, now what we want to do is to calculate tokens for each description and sum them up, and then we are going to calculate the cost. So we'll say the following. We'll say total underscore tokens is equal to sum of length of encoding dot encode, then say item for item and description. So here in this line of code, we are calculating the token for each item in the descriptions. So we are calculating the token for each description, and then we are sum them up here. Okay, now after this we'll say print f total tokens is total tokens, and then we are going now to calculate the cost. So we'll say cost is equal total underscore tokens multiplied by 0.0004 divided by 1000. So here we are calculating the cost per token. It can vary based on the OpenAI model we are using. Be sure to check the current price from the OpenAI website. And then we are going to say print f estimated cost in USD. We'll say here it's the cost of 10f. Let's run now the code and check the total cost. And I get an error because I made a mistake here. This is supposed to be here in case you face the same error. Now let's run the code again. And this is the total cost estimated in USD dollar, 0.004. In the next part, we are going to embed the description and cache them locally. Alright, what we have done so far is load our dataset, clean the data, and calculate the total cost of embedding. Now in this part, we want to create a function that will calculate the embedding for the description and save them locally. But why do we want to save them locally? Because we don't want to recalculate this embedding every time. So we are going to define two functions in this part, one function to get the embedding and the second function to save the embedding locally. Let's first define the function that will get the embedding. So we'll say here, define get underscore embedding text. It has two arguments, the text and then model. By default, we are going to use text dash embedding dash 3 dash small. We'll say here text is equal to text dot replace new line by empty string. Why do we do that? We are going to replace a new line with empty string to remove any new line character to help OpenAI process the description cleanly. After that, we are going to say return client.embeddings.create, and the input it's equal to text and the model is equal to model and dot data 0 dot embedding. So here the client.embedding.create part is where we send our text to OpenAI powerful language model, and we are specifying the embedding model to use. This choice impacts the type of embedding generated. Data 0 at index 0 dot embedding, this extracts the actual numerical embedding, our magical book representation from OpenAI response. Let's run the code, and it's working. Now we want to create a function that will orchestrate the whole embedding process. First, it has to create a new column called embedding in our data frame. We want the embedding in the same data frame for each book. And then we are going to call this function that we just created, get embedding, to each description in our dataset, calculating the embeddings one by one. After that, the third step, which is very crucial, is to save our updated data frame with the embedding to a file called book_embedding. Alright, let's write the code for this. So here we'll say define get underscore embedding underscore and underscore save to CSV. This function will have only one argument, which is the name of the CSV file. We'll say embedding underscore cache underscore file. As I said, we have to create a new column called embedding. So we'll say data frame embedding equal, and then we are going to say here data frame description column dot apply, and then we'll say here lambda x, and we are going to call now the function that we just created, get embedding x model is equal to text dash embedding dash 3 dash small. So we are calculating the embedding for each description one by one. And then we are going to say here, we are going to save the file. We'll say data frame dot to underscore CSV and the embedding cache file name. Alright, let's run the code and make sure it's working. And it's working. So to sum up again, here we created a function that will calculate the embedding. We will pass here the text, and we are specifying the model text embedding 3 small. Here we are calling our OpenAI client. We are calling the embedding module, and we are calling the create Here we are passing the input as text and the model is the model here, and we are returning the embedding. Okay, now in this function we are creating a new column called embedding in our data frame, and then for each description here we are applying our embedding model here, and at the end we are saving to locally to a CSV file called embedding cache file, which will contain our data frame with the embedding. All right, let's now define a variable called embedding cache file. So we'll say here embedding underscore cache underscore file is equal to book underscore embeddings.csv. This will be the file name where we will store the calculated text embedding. Next, let's call our function. So we'll say here get underscore embedding and save to CSV, and we are passing the embedding underscore cache file. Let's run the code. It's gonna take some time because it's going to calculate the embedding for each description. I'm gonna pause now and resume once it's finished. And it's done. So what happened here is this function has the following core responsibility: calculate embeddings, iterate through our descriptions in the data frame, and generate text embedding for each one using our OpenAI model. Store the embedding, add a new column named embedding to our data frame, and store the calculated embedding. And the third responsibility is to save to file. It will save the entire updated data frame, including the book details and embedding, to book underscore embedding.csv file. So let's have a look now at our data frame. So if we set df and run, and we go here to the end, we see here the new column which is called the embedding, contains the embedding for each book here. All right, by this we reach to the end of this part. In the next part we are going to load the embedding from the CSV file stored locally and start working on the function to get the recommendation from the title of the book. In this part, we are going to load the book underscore embeddings.csv created locally in the previous step. When we saved our embedding, they were stored as text that looks like list. We need to convert these back into the numerical array that our calculation expect. So we are going to evaluate the text representation of each embedding and turn it back into a list-like structure. Okay, so we'll say here, we are going to define a new data frame called data frame embeddings is equal to pd.read underscore csv, and we are going to pass here embedding cache file. All right, let's see how it's look underscore embedding, and we get our data frame. All right, so we need to evaluate the text representation of each embedding and turn it back into list-like structure. So here what we'll say, df underscore embeddings, column, and then we'll say equal to df embedding dot apply eval dot apply numpy dot array. This will convert those lists into a proper numpy array, perfect for applying math calculation. And now let's have a quick peek at the new data frame embeddings, and it's working. And as we can see here, we have the embedding and all the book information. That's it for this part. In the next part, we are going to work in the function to get the recommendation from the book title. In this part, we are going to create the get recommendation function from the book title, which is the heart of our recommendation engine. Let's bring down how it works. First, this function will accept two arguments: the data frame with embedding, which we just created, the book title that we are looking for recommendation for it, and the number of recommendation, how many recommendation we want, 5, 7, and so on. The first step, we are going to check if the book exists. We want to make sure that the user input the title that is actually in our dataset. If not, we are going to return false. Then this function will locate the book the user entered in our data frame, which is the df underscore embedding, and will extract its embedding. Then we are going to create a list containing the embedding of every book in our dataset. After that, we are going to use cosine function from SciPy, where it will calculate how similar our input book embedding is to every other book embedding. Smaller distance mean similar books. And then we are going to use numpy.org sort, which is a function to get the top matches, and it cleverly sorts the distance, and it will give us the index of the closest matches. And finally, we are going to build the recommendation list by carefully construct a list of recommendation. Each recommendation will be a dictionary, contains the title, description, and distance, which is the similarity score of a recommended book. And please note, we are going to skip the first closed matches of index 0 because that's the input book itself. So let's start now defining our function. So we'll say define get underscore recommendation underscore from underscore title. We'll say it will have 3 arguments: embeddings and title and key. So it has 3 arguments: the data frame with the embedding, the book title, and key is the number of recommendation we want. First, we have to import cosine from the SciPy library. So we'll say from SciPy.spatial.distance import cosine to calculate the cosine similarity by calculating the distance. As we said, smaller distance means similar book. First step, we are going to check if title is not in the list in our data frame. If not, we are going to return false. So we'll say if title not in list data frame underscore embeddings title, and then we are going to say return false. Next, we are going to say book underscore embedding is equal to data frame underscore embedding, and we are saying data frame here underscore embeddings title equal title, and here we are going to say embedding dot I location 0. We are extracting here the embedding for the book entered by the user. Next, we will say here embeddings is equal to list df embeddings. Here we are extracting the embeddings for all the books in a list without s. Now we will check the distance. So we'll say here distances is equal to cosine, and then we'll say book underscore embedding, and then emp for emp in embeddings. This will calculate the cosine similarity. It will compare each embedding in the list here, in the list of embedding here, to the book embedding. Next, we will say closest underscore indices is equal numpy dot arg sort, and we'll say here distances, and we are gonna take the k nearest embeddings. All right, Now let's create an empty list of recommendations. So we'll say here recommendation is equal to an empty list. And then for index n clauses indices, we'll skip the index 0 because it is the index of the entered book by the user. And we are going to go to k plus 1. So I'm creating a loop for each book inside the closest underscore indices. And then now we are going to create the dictionary. So we'll say book is equal to an empty dictionary. Then book title is equal to df underscore embedding dot I location with the index, and then we are taking the title. Okay, same thing for the book description is equal to df underscore embedding dot I loc index description. And also for book distance is equal to distances index. And then we are going to say recommendations dot append book. And finally here this function will return recommendations. Now let's demonstrate how to use this function. So we'll say here get recommendation from title. We are going to pass our data frame, and the title of the book we are going to use. I know there's a book called Irish Anatomist, and I want the top 10. Let's run the code. And we get the list here. As you can see, the title of the book and the description and the distance. Alright, by this we reach to the end of this part. In the next part we are going to do some improvement of the result here. In this part we are just going to do some application enhancement. We are going to define the following. Title is equal to input enter book title. We are asking the user to enter the book title, and then we are going to say here book underscore recommendations is equal get recommendation from file. We are using the data frame with embedding title, and we want 5 recommendation. Then we'll check if book underscore recommendation is not false. And then we are going to iterate over each item in the list of dictionary, enumerate, and then we'll say here book underscore recommendation. We're going to say print f book recommendation number I plus 1 because it starts from 0, distance item distance and this. Alright, and then we're going to print now the title. Say f title is item title, and we are going also to print the book description. So we'll say here description item description, and we want to add separation between each book. So we'll print first an empty line, and then print, for example, 50 star times 50, and also empty line. And if the result was false, we are going to tell the user that his book does not exist in the list. So we'll say F title does not exist in the dataset. Let's run the code, make sure it's working. Yeah, it's asking us to enter the book title. Let's enter anything just to test. Title Atif Ataya does not exist in the dataset. Let's run this code again. Let's now enter, for example, Bill Gates, which I know that exists in the dataset, and we get the recommendation with the distance here. We see here the title, The Last Lion, describes the early life and political career of a British Prime Minister. So it's also a recommendation to the book that we have here. Okay? So this part brings our recommendation system to life. So let's summarize what's happening here. A conversation starts, we ask the user for a book title, and then we feed that title into our recommendation engine, which works hard to find similar books. And finally, we either present a nicely formatted list of recommendations or let the user know if their book is not in our system. Okay? In the next part, we are going to see how we can display the embedding on Atlas. Alright everyone, our AI-based recommendation system is done, but I still want to show you something related to embedding, which is very useful. As we have seen, embedding encodes semantic or text information in a numeric vector. You encode document to perform vector operation to find similarities for different purposes, such as recommendation system, anomaly-based detection, semantic search, clustering, and so on. Embeddings are useful, but hard to understand. For example, these are the embedding for the book's description used for the project done in this section. And this is the embedding for the first book description. As we can see, it's difficult to understand it. So in this part of the tutorial, I will show you how to visualize embedding, so that you could see the relationship between your vector through human eye. And as embeddings are vector representation of your text, they also reveal the hidden connection between documents within your text dataset. We will use a service called Atlas, which is a machine learning tool used to visualize large unstructured dataset of embeddings, text, and images. It's like a standard NoSQL document engine. OpenAI embedding are represented as 5136 dimension vector, where each dimension captures some aspect of the input. We cannot deal with such a large dimension vector, so Atlas will produce a two-dimensional map of the embedding. So if we check the book recommendation system example here and open the map, it is made of clusters, where each cluster signifies a collection of related embedding joined due to semantic reason. You can individually hover over the dots to examine the text and deduce the distance, while OpenAI embeddings model view this embedding group as alike. They are all related to the book name. So here, each dot here is the representation of the book. When you click on it, you can check here the name of the book changed. Okay? And for example here, this shows that all these books related to each other. For example, this book titled Founding Brother, the category of it is biography and autobiography. And if we click here in this book, it's also with the same category. So it's similar to it with a close distance here. So Atlas helps us visualize these text embedding and check the distances. Additionally, Atlas will also identify clusters of similar embedding and strive to provide a summary for our convenience. You can zoom in or zoom out or search for specific book here. For example, if we go here to the search, we can search, for example, the title and choose, for example, Bill Gates, and we can find the book here. So now how we can integrate our Atlas into our Jupyter Notebook. The first step is, of course, to sign up for a free account on atlas.nomic.ai. I have already done that, so I will skip this step. The second step is to install and set up the Nomic Python library. So you have to go to the terminal and type pip install nomic and then press enter. Next, type nomic login, and to get your API token used for authentication, Click this link or copy and paste it into your browser address bar. You have to be already signed into your account. Click create a new API key. I have already created my own API key. This is the API token used by the Nomic Python client to securely connect to your Atlas account. Copy it to a secure place because you will need it. Return to the terminal and run Nomic login and paste the token and click enter. Alright, the authentication part is done. Now let's go back to the Jupyter Notebook. Now in Jupyter Notebook we'll say from Nomic library import Atlas. After that we'll say embedding underscore cache underscore file is equal to dot slash book underscore embeddings dot csv. Then df is equal to pd.read underscore csv, and we are passing the embedding cache file. Let's have a look at our data frame, and we have the data frame as before with the embedding. Next, let's make sure that the embedding column is formatted as a NumPy array, which Atlas expect. So here we will say data frame embedding is equal to data frame embedding dot apply eval dot apply numpy dot array. Let's run the code. It's done. Next, we are going to select the title, author, category column from our data frame. This information will be used to label and provide context for the visualized book in Atlas. So we'll say data is equal to data frame, and we are selecting the title, authors, categories, dot to underscore dictionary records. The to underscore dictionary record part formats the data in a way that Atlas like. And then we'll say here data. Let's run the code. I made a mistake here. This should be like this, records. Okay, let's run the code again. And we get the dictionary. We have the title, author, category for all the books. Okay. Next, we will grab the embedding from the data frame and convert them into NumPy array. This is a format that Atlas understands. So we'll say here embeddings is equal to list of data frame embedding, and then we'll say here embeddings is equal to NumPy array embeddings. Okay, after that we will say project is equal to Atlas dot map underscore data, and we are going to pass embeddings is equal to embeddings and data is equal to data. This part here is where the magic truly unfolds. The atlas.map underscore data does the heavy lifting. Embedding equal embedding, we feed in our book embedding the numerical representation, and then data will provide the book title, author, categories to associate each embedding point with these properties. Now let's run this code cell and make sure everything is working fine. It's creating the data set and uploading data to Atlas. Upload successfully, and this is the name, Maxwell data uploaded succeeded to dataset. Okay. Now if we go back to Atlas, we can see now here in Atlas the dataset uploaded, and we can visualize the relationship between the embedding. Alright? Building this project, we saw the importance of cost awareness when using AI tools, and how this magical embedding turn words into something our code can understand. Remember, AI is a powerful tool. Use it responsibly. Share your feedback. Let's keep learning together. If you enjoyed this, please like, subscribe, and let me know in the comment what other AI project you would like to see. And also please note that this recommendation algorithm can be applied to any other type of products such as music, movies, TV series, and so on. The possibilities are endless. Keep exploring and building with AI. Alright everyone, that's it for today's tutorial. I hope you enjoyed it and you learned something new. Don't forget to subscribe to my channel for more tutorials like this. Happy coding and see you in the next tutorial.